Hi, I'm Dane Calkins of Legacy Woodworking Machinery. I appreciate your interest in the hollow spiral plate rack project.
On this video, you'll learn the fundamentals for creating successful hollow spirals. In addition, we'll show you how we use the Legacy to create many of the construction details on this project. We'll begin by cutting the two sections of hollow spiral. The material started out 2 inches square and we knocked the corners off on the table saw. These two parts should measure 13 inches in length. You will need two router bits, first a 1 1/2 inch barley twist bit, and second a 3/8 inch diameter upcut spiral bit. Because we will be moving the parts in and out of the machine, it's a good idea to mark the prong of the mounting hub and the corresponding hole on the drive center. This will ensure that the registration of the part as we go between the operations. Using the 1 1/2 barley twist bit, we will mill the first cove. The stops are set with the router locked into place at 2 inches. The cut gets made a little time by bringing the router in from the side. The outside diameter of the part should measure approximately 1 7/8 inches. The second cove is made with the router positioned at 3 1/2 inches. And the third cove is milled with the router at 11 1/4 inches. The area between the second and the third cove measures 7 3/4 inches and will be milled into a 3-start barley twist.
Let's take just a minute here and review the formula for creating the barley twist. You'll remember that the formula says that the diameter of the bit is multiplied by the number of starts to equal the pitch. In this case, we're using an 1 1/2 barley twist bit, and we want 3 starts. 4 1/2 inch is the pitch.
Therefore, 4 1/2 inches, or the D drive gear, is the gear pitch being used on these parts. The first part being created has a left-hand cut. You can start with whatever directional gear you have on the machine. The directional gear will get changed when we go to mill the second part. Remember that when we're milling spirals, we lock the split nut onto the lead screw. Once the first spiral cut has been made, we slide the router over 1 1/2 inches, or the diameter of the router bit, and lock it into place at 9 3/4 inches. We then drive the router back to the beginning. The second spiral cut is made right next to the first cut. Notice that this leaves an uncut section that is also 1 1/2 wide, which is where we will mill our third cut. And there you see the completed 3-start barley twist. The second part is the same size as the first. We also marked the prong of the hub, just in case we had to take the part in and out of the machine. The first part was created using the left-hand directional gear. It will now be necessary to remove the left-hand directional gear and install the right-hand directional gear. Note that it has 2 gears between the sleeves. Once again, we make the cove cuts at 2 inches, 3.5 inches, and at 11.25 inches by bringing the router in a little at a time while rotating the workpiece. Repeat the procedure to create the 3-start barley twist. Notice that this part has the spiral being milled with a right-hand twist. Once you lift the router bit out of the workpiece, you can drive the router back to any position you wish. We chose an even number, in this case 10 inches. Now because the router bit is 1.5 inches, we now open the split nut and slide the router 1.5 inches to 8.5 inches and lock it into place. We are now positioned for the third and final cut.
The biggest problem we face when creating the hollow spirals is keeping the part from blowing out.
Hollow spiral blowouts are caused when the splines become weakened as more material is removed. Less material means an increased chance of bounce or chatter as the router bit cuts the part. You'll find your success ratio will increase dramatically if you can support the splines as they are being milled. Here are 2 ideas that will increase your chances of success. The first method is to cut small blocks, the same width as the diameter of your router bit, and insert them between the splines as you are milling. You will want to tape them into place, of course, otherwise they will have a tendency to vibrate loose. The second method is to use the Legacy thin stock support, which helps hold the splines. The support is placed in the center of the piece and keeps the splines from chattering. Notice that the workpiece has been rotated such that there are 2 points where the support block meets the bead created by the barley twist. At this point you can lock the support block into place. Now as you slide the second support block up against the piece, rotate the part so that the second block also touches on 2 points. This will ensure that the blocks are aligned evenly with the part and will render the maximum support to the part as it is being milled. The 3/8 inch upcut spiral bit is positioned between the 2 beads, and then we lock the split nut onto the lead screw. This will verify the exact position of the router bit. Using the lead screw, drive the router back to the 4-inch mark on the scale and lock the stop collar against the split nut. Notice that the handle is positioned straight up. To remove the backlash, we rotate the handle 1/2 turn to the down position. This will advance the router 1/8 of an inch to remove the backlash, which is inherent in the gears. The cut then gets made with the router plunged down 1/8 to 1/4 of an inch deep. We rotate the handle and advance the router as the workpiece rotates. In this case, we will end our cuts at 10 5/8. You can set your stops or just use the scale and pointer. Lift the router out of the material and drive it back to the beginning stop at 4 inches. Advance the router a half turn to remove the backlash and plunge deeper on each consecutive cut. Again, don't forget to remove the backlash by advancing the router a half a turn or 1/8 of an inch. When you're ready to move to the second and third beads, simply open the split nut and slide the router 1.5 inches, the same as when we created the original barley twist. As you plunge deeper on each bead, the hollow will magically begin to open up. And there you see the completed 3-start hollow spiral. We will follow the same procedures on the second part. However, it will be necessary to change the directional gear. You'll also want to remember to align the hub and the drive center back to its original location in the machine. The tenons of the hollow spiral plug into the side panels on each end, and the central recipe box, which is used to space the two sides apart. Use the same 3/8 inch upcut spiral bit which was used to create the hollow. The router is locked into place at 12 1/8 inches for the tenon on the tailstock end. The tenon should be milled to a diameter of 1/2 inch. The tenon on the headstock end is milled with the router positioned at 1 7/8. Once the tenons have been milled on each end, cut the waste off on the bandsaw. The easiest way to sand the parts is to use sanding mops on your drill press. These are available from Klingspor Abrasives. Their phone number and web address is available on the tool list portion of your shop notes. We also use the Legacy to create the finger joints for the recipe box. First we will mill a 1/4 inch groove or dado along the edge of our material. This groove will be used to hold the bottom of the drawer into place. Our material is 2 3/4 inches wide and 20 inches long. It is secured to the horizontal vices using the cam locks. The depth of the cut is half the thickness of the material, or 1/8 of an inch. Here you can see we are using feeler gauges to determine the depth. We can now remove the material and cut it to its proper lengths. Cut 2 pieces 2 3/4 inches long and 2 pieces 5 7/8 inches long. Tape the material together with the dados facing each other. You may want to back the panels up as shown here to eliminate any tearing out of the material as the bit comes through. The vertical vices mount to the rails of the horizontal vices. The material is then mounted into the vices with the cam locks. To determine the proper depth of cut, start by plunging the 1/4 inch upcut spiral bit down on top of the material, then use a piece of material that is the same thickness as your box panels to set the plunge bar on the router. The router is then plunged down to the proper depth. The cuts are made with the router advanced 1/2 inch each time, 1/4 inch for the cut and 1/4 inch for the finger, equaling 1/2 inch spacing. Because the lead screw is 1/4 inch thread, we could advance the router with 2 turns of the handle, moving the router tray 1/4 of an inch with each rotation. We now flip the part and make the same cuts on the opposite end. Don't forget to readjust the plunge depth of your router. The cuts are then made in the same manner as previously shown. With the Y-axis open, we simply slide the router across the stock. Again, we advance the router 1/2 of an inch and then make the cut. Keep in mind that in order for the panels to match up properly, you want the front and back panels to have the fingers milled opposite the two end panels. To ensure that the plates don't slide along the back panel, we place self-adhesive bumpers in strategic locations. If you prefer, you can drill holes and use dowel pins for support. This concludes the hollow spiral plate rack video. Use the drawings and notes provided to complete the back and side panels, and now let's go have some fun.